Hello students, we discussed about one functions in the previous video. So in this video we will learn about inverse functions, inverse of a function. So by definition I already introduced inverse of a function in the previous video where I told you that only one functions can have inverse functions. So why is that? So let us see a function which is not 1 sorry. Yeah, if there are two sets A and B where A is the domain and B is the codomain, and you have X, Y, Z and P and 1, 2, 3, 4 and 5. So you have a function F which is not 1. Let us say it is not 1. So X is also going to 2 and Y is also going to 2. Then Z is going to 3 and P is going to 4. So this is clearly a function but not a 1 function, right? So suppose if for the inverse to exist, then the codomain will become the domain of the inverse function. Codomain will become the domain of the inverse function. So this will be the domain for this will be the domain of the inverse function. So you will have B to A, and that should be defined by the same function F that you consider here. So 1, 2, 3, 4, 5 X, Y, Z, P. So you will go in the reverse direction, that is from B to A. So your F inverse will be mapping all the elements from B to A as it is being mapped by F. So you can see that 2 is mapped on to X and Y. So this is not at all a function in the first place, right? So that means that the F inverse does not exist if the function is not 1. I hope you got the point. So let us now define a function, inverse of a function. So definition, let F be a 1-to-1 function with domain A and range B. Then its inverse function F inverse has domain B, as I explained earlier, has domain B and range A, and is defined by F inverse of Y is equal to X if and only if F of X is equal to Y. So this is the process, that is Y is the image of X under F function. So when you have F inverse of Y is equal to X, so that would be the inverse image of Y would be X. So that is what the function says, and that is what we did earlier, that is above, and we established that if a function is not 1, F inverse will not exist. Using this definition, let us solve some problems. For example, I will go for an exercise problem. So finding the values of an inverse function, assume that F is 1-to-1. So it is already given that whatever function they are giving as a question will definitely be a 1-to-1 function. So this is exercise number 26 in the book. So A is F of 5 is 18. So find F inverse of 18. So by the definition above, it says that F of X is equal to Y, then F inverse of Y will be X. So here x role is played by 5 and y role is played by 18. So using the definition, what will be f inverse of 18? It will be 5. Okay, so next problem, it is a sub question in the 26th problem. If f inverse of 4 is 2, find f of 2. Okay, so here y is played by the role of 4 and x is equal to 2. Okay, so what is f of x? By using the definition, f of x will be y, that is f of 2 is 4. I hope you got the point, and let us move on further. We can identify this using graphical method too. So that would be number 30 in the book. I don't know how far I'll be able to draw the graph for perfection. I'll try. Okay. I'm sorry. Yeah, I will need this graph. Okay, so this is our y-axis and this is our x-axis and this is the origin. So we have 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8. Okay, so the graph looks like this. It goes from 0 to 4. Okay, up to 0 to 4. This is 1 2 3 4. Okay, it reaches here, and after 4 it raises. Okay, it raises a unit. Okay, I don't know where I'm erring. So 5 will be mapped onto okay, I'm wrong in drawing this straight line. So 4 is reached at 2. So this is the first line, and then the graph raises to 5 like this and moves on like this. Okay, imagine this line to be a straight line, or else I will draw a straight line. Okay, yeah, the graph looks like this. So now we are asked to find out A is G inverse of 2. So what is G inverse of 2? First, for that we need what is G of where is 2 is on the y-axis. So which is the pre-image of 2? So here is our 2. So moving further, so it is here, correct? So the input for which the output value is 2 is 4. So G inverse of 2 is 4. Next question is find out G inverse of 5. So which is our output value 5 is here. So go further till it touches the graph. It is touching the graph here. So come down to the x-axis. So x-axis value here is 5, 6, 7. So G inverse of 5 is 7. Okay, so then G inverse of 6, with the same method, find out what is G inverse of 6. So 6 is here. Okay, go further till it touches the graph. It is touching here. Come down, it is 8. Correct? The value of G inverse of 6 is 8. So this is how graphically you identify the inverse values of a function. So this is reverse process of plotting a point. So how are you plotting a point? First you are walking along the x-axis and then reaching the from there rising above the y-axis. But now you will walk along the y-axis first if you are asked to find out inverse of a number. Then walk along till it touches the graph and come down to see which is the input value which is giving that particular output. Okay, moving further, we will learn about inverse function property. So inverse function property states that let inverse function property, function property says that let f be a one-to-one function. So it's a one-to-one function, and with domain A, the domain of f is A and range B. So what I call as codomain is the whole of the set that has the image set, but range is just something that consists of image set. Okay, range B, the inverse function f inverse, the inverse function f inverse satisfy the cancellation properties, satisfies the following cancellation properties. So what are the cancellation properties? If f inverse acts on f of x, you will get back x. And if f acts on f inverse of x, you will get back x. This is true for every x belonging to A, and this is true for every x belonging to B. So that means this statement implies that f inverse is the inverse of f, and this statement implies f is the inverse of f inverse. Okay, so if f is 1-to-1 and if it has an inverse function, so it satisfies these two properties. Let us use it to find out inverses of a function. Going back to exercises again. This is exercise number 40. Use the inverse function property to show that f and g are inverses of each other. So f is given to be 2 minus 5x and g is given to be 2 minus x divided by 5. Okay, using the property here f inverse and f. So if f is an inverse of g, it should satisfy any one of these two property, right? So if f is an inverse of g, f times g of x should be equal to x itself. Let us check this. So times in the sense composition. F composed with g of x is nothing but f of g of x. But what is g of x? G of x is 2 minus x divided by 5. Okay, so when you go to the function f, wherever you have x, you substitute this whole of the fraction. So you will get 2 minus 5 times 2 minus x divided by 5. Okay, so simplifying this further, this will be 2 minus x plus x. Sorry, 2 minus 2 plus x. So 2 and 2 will get cancelled. You are just left with f. So by the inverse function property, f is the inverse function of g. So to do the vice versa, you are asked to check f and g are inverses of each other. So you also have to check g is the inverse of f. So for that, apply g composed f on x and check whether you are getting back x. So whether you are getting back x. So this will be nothing but g of f of x. So what is f of x? F of x is 2 minus 5x. Okay. So in g, wherever there is x, substitute this whole polynomial. So you will be getting 2 minus 5x minus x divided by 5. Correct? Okay. Did I do something wrong? 2 minus x. I'm wrong. Okay, I'm sorry. Yeah, what was g? It was 2 minus x divided by 5. So that will be 2 minus 2 plus 5x divided by 5. I'm sorry. So 2 minus 2 will get cancelled. You are left with 5x by 5, and 5 also will be cancelled, and you are left with x. So this implies g is the inverse function of f. So we verified that f and g are inverses of each other. I will do another problem in this case. Problem number 42, which is f of x is equal to x power 5 and g of x is equal to 5th root of x. Again, you have to verify one is an inverse of the other. So both are inverses of each other. So for that, if I calculate f compose g, I will be getting f of g of x. So that is nothing but f of 5th root of x to the power of 5. That will be nothing but 5th root of x to the power of 5. Sorry, 5th root of x, whole to the power of 5. Correct? So you are raising, this can be written as 1 over 5 times 5, right? So 5 by 5 is 1. So you are getting back x. Doing the opposite, that is, this implies f is an inverse function. F is the inverse function of g. So to find out whether g is an inverse function of f, do this. G of f of x is equal to g of x to the power of 5, that is equal to 5th root of x to the power of 5. So this will be x again. So I'll do another problem where domain is being mentioned. So this is problem number 46. F of x is equal to 4 minus x square, 0 less than or equal to x less than or equal to 2, and g of x is equal to 4 minus x square, 0 less than or equal to x less than or equal to 2. So this is, both the functions are same. Okay, let us do this. Calculating f compose g of x, we get f of g of x. So that would be f of square root of 4 minus x square. So this will give us, wherever there is x, you should substitute the whole of this. So that would be square root of 4 minus square root of 4 minus x square the whole square. Okay, that you will be getting back square root of 4 minus of 4 minus x square, correct? So this would be square root of 4 minus 4 minus plus x square. So this will be square root of x square, that is x itself. So the process is one and the same because the functions are same. So this will be equal to g composed with f of x also. So they are one and the same. When you are asked to find out an inverse giving one function, the domain matters, but it doesn't matter when you are checking one function is a inverse of another function or not. So you will learn the next process where you solve for y and replace the terms and things like that. Then you should be very careful if you are given a domain. Okay, let us learn that method. Okay, how to find inverse of a one-to-one function. This is another method. No, we never learned any method to find inverse. We just verified inverse, right? So how to find the inverse of a one-to-one function. So there are steps. First one, okay, write, I'm sorry, okay, write y is equal to f of x. Second, solve the above equation for x in terms of y. Okay, third, then interchange x and y. Interchange x and y. So you will get the resulting equation to be y is equal to f inverse of x. So this is how you find out the inverse function. We will use this procedure and solve some problems. This is problem number 50 in the book. You are given the function f of x is equal to 7 minus 5x. Okay, what is the first step? We have to write y is equal to f of x, right? So write y is equal to 7 minus 5x. Then solve the equation for x. So to solve the equation for x, this will be y minus 7 is equal to 5x. Then this will be equal to y minus 7 divided by 5, sorry, negative 5 is equal to x, correct? So this will be equal to, if you take the negative sign to the numerator, that would give us 7 minus y divided by 5 is equal to x, correct? So this is our step number 2. Step number 3 is interchange x and y. So interchange x and y, you will get y is equal to 7 minus x divided by 5. So our inverse function is y is equal to f inverse of x. So that is equal to 7 minus x divided by 5. So this is the inverse function of given f of x. I'll do another problem. So this is problem number 58. This is kind of a rational function. So f of x is equal to 4x minus 2 divided by 3x plus 1. Okay, so the first step says that we should write y is equal to f of x. So y is equal to 4x minus 2 divided by 3x plus 1. Okay, so now we should solve for x in terms of y. To do that, I will do cross multiplication. So this would give us y times 3x plus 1 is equal to 4x minus 2, correct? Okay, so this implies 3xy distributing y inside the polynomial 3x plus 1, we get 3xy plus y is equal to 4x minus 2. So bring all the like terms or the terms with x towards one side. That we will get it as 3xy minus 4x is equal to minus y minus 2, correct? So now take out x as common. X times 3y minus 4 is equal to minus y minus 2. So now you can write it in x is equal to minus y minus 2 divided by 3y minus 4. So this is same as x is equal to y plus 2 divided by 4 minus 3y. Okay. So now the last step is interchange x and y. That implies y is equal to x plus 2 divided by 4 minus 3x. This is nothing but our f inverse of x. Okay, I will do another problem where you have a domain. As I said earlier, like the restriction of the domain is very much important when you are calculating the inverse of a function. So this is number 62. F of x is equal to 1 over x square, where x this is not a problem. 62 says that f of x is equal to x square plus x, where x is greater than or equal to negative 1 over 2. Okay, this is actually the domain of the function f of x. Okay. Now coming to the steps, what is the first step? We replace y is equal to f of x. So write the equation as such: y is equal to x square plus x. Then what do? We solve for x. So y is equal to x of x plus 1. So that implies, okay, how do we solve this? Yeah, this is a kind of a little tricky problem. Okay. X times x or x times x plus 1 is equal to y, or let us use the quadratic formula. Okay, so that would be y is equal to x square plus x. So x square plus x minus y is equal to 0, correct? So now what is our a is equal to 1, b is equal to 1, c is equal to negative y. So our x will be equal to plus or minus, negative b minus b plus or minus root b square minus 4ac divided by 2a. So this would be negative 1 plus or minus square root of b square is 1 minus 4ac. That would be plus 4y divided by 2. So this is equal to, so x has two values, negative 1 plus or minus, plus square root of 1 plus 4y divided by 2, and x is equal to negative 1 minus square root of 1 plus 4y divided by 2. Okay, so now if you interchange the variables, so f inverse of x will be equal to negative 1 plus or minus square root of 1 plus 4y divided by 4x divided by 2. So here we have to create our own domain, because we should not have negative values inside the square root. So for that, if we calculate what gives negative value, when will this term be negative? When x takes when x takes values greater than 0, correct? When x takes values greater than when x takes values less than 0, we get negative terms inside the brackets. So we are avoiding the values of x should never be less than 0. So therefore the range is x is always greater than or equal to 0 in this case. So if you have a range that is present in the original function, you will definitely have a range or domain and range that is present in the inverse function also. You need to mention that and calculate that. Okay, with this I will end this video here. I will give all the quiz questions in the last video, that is the next video that I am going to post very soon. There we will learn about finding the inverse of a function or graphing the inverse of a function, and we also learn how to graph that, draw a graph of the inverse of the function, and how to restrict the domain and find inverse function using graphs. So see you soon. Thank you for listening.